Very good morning, one and all. Myself, D.Jyothi, Assistant Professor, Department of CSE Data Science, MLR Institute of Technology, Hyderabad. Welcome to the lecture series on data analytics using R. Today, we are going to discuss about the matrix. So, we'll be discussing about the matrix, basic definition of the matrix, and we are going to have a discussion on few of the examples of the matrix. So, look at here, what is a matrix? Matrix is a collection of elements of same data type. So, you cannot mix a character and string like that. You can have different vectors. You can have a string matrix, you can have a numeric matrix, you can have a character matrix, or you can have a complex matrix. But character matrix and string matrix, it should not be mixed. So, these are arranged in a fixed number of rows and columns. And the matrix is called as a two-dimensional data structure because it is having the rows and columns. Matrix need to be created with the matrix function, matrix built-in function. Look at here, the creation of a matrix. For creation of the matrix, as we have discussed, the matrix built-in function need to be used. And we are declaring the variables, numeric numbers here. For declaring the numbers, I am using the sequence here, 1:9 I am writing here, and I have specified only a number of rows. When you specify the number of rows, number of columns will be automatically taken. If the one parameter is given, another parameter will be automatically taken. Look at the output here, how the values are arranged. So, I have given 1:9. So, the values from 1 to 9. Look at here how the values are arranged, 1, 2, 3, 4, 5, 6, 7, 8 and 9 in the output. But when you want your data to be arranged in a row wise format, so then you have to use by row equal to true. So, I have the values 1:12 and I am using by row equal to true here. So, my values will be arranged according to a row. Now, observe the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Understand the difference between when you use by row equal to true and when you don't use by row equal to true. We can name a matrix. And here I am taking an example. In Kenya, I have some numeric values there in Kenya variable, and Ethiopia also I have some numeric values I have stored. In Chad also I have stored some numeric values. Now look at here, I am specifying the n row equal to 3 and by row equal to true. I am using, so here I am defining it as a vector, a numeric vector, and here in the matrix I am using the vectors here. Kenya I have some values, Ethiopia I have some values, and Chad I have some values. Now look at here, I have defined one more variable. In that variable I am storing latitude and longitude. And I am having countries here. I have a Kenya, Ethiopia and Chad. I am declaring the country names and I am storing in the variable countries. Now, instead of manually giving the values, what I do is, whatever the values I have declared in the location, that values I am assigning to the column names. So, column names is a function for naming the matrix, and row names is a function for naming the rows in a matrix. Now, I am trying to print the geometry matrix. Observe the output here. So, here whatever the values I gave by using the column names and row names, that values will be getting at the column and row. So, adding one more column. For this one, the assumption is you already have a matrix available and you are adding one more column to the matrix. So you have you have already matrix available and you are adding one more column to the matrix. Look at the example here. We will be using cbind function. Cbind function to add a column to a already existing matrix. X is a matrix that we have created. In that I have 1 to 9 and these are arranged. Number of rows are 3 rows. Here I am using a cbind function and I am taking a matrix. I am adding one more column to the matrix, that is 1, 2 and 3. So look at here at the end, this is an already existing matrix that we have already created, and here whatever the value just now created, that will be by using a cbind function, that will be added to the matrix here. Adding a row to a matrix, we will be using the rbind function. For these also you need to have the matrix available. For the existing matrix only, we will be adding one more row to the existing matrix. The same example, 1 to 9 elements are there, and you are specifying the number of rows are 3. And look at here, this is already existing matrix. And by using a rbind function, you are adding one more row to the matrix, that is 1 to 3 elements you are adding to the already existing matrix here. The matrix indexing, the same example, 1 to 9 elements, and n row is 9. So look at here, you are selecting only second row of the matrix and you are selecting only third column of the matrix. The row need to be specified here and the column need to be specified here. So the index of a matrix is row comma column. You want only a single row. You have to specify in the row index place, you have to specify it as 1. You want a second row. In the row index, you have to specify second row. In the column, you want a first column to be defined, means printed. So you have to specify it as 1. Here, selecting the second row, this is the output. You have selected a single row here. And selecting the third column, this is the output. You have specified only the third column. So we can apply arithmetic operations on a matrix. Look at here, we have the mat 10 and mat 11 matrices are created already, and we are applying. Look at here, we are not applying anything here, just the values whatever we have stored in mat 10 and mat 11, I am displaying the values here. And now I am adding a scalar 10 to the mat 10. Mat 10 matrix is already there. This is the mat 10 matrix. This is the first matrix. To these I am adding a scalar value 10. So look at the output. This is the output before applying the function. After applying the function, you will be getting. So 10 will be added to each and every element of mat 10. Like that, you can add 2 matrices and subtract 2 matrices. You can apply all the arithmetic operations on the matrices. Observe the outputs here. And you can multiply a scalar value, any scalar value to with a matrix. I am multiplying 2 with a mat 10, and here I am multiplying mat 10 with mat 11. Look at the outputs. This is the output for multiplying 2 a scalar value with a mat 10, and here I am multiplying 2 different matrices. We can have the transpose of a matrix. This is the built-in function we have to use. T is the built-in function we have to use, and the transpose of the matrix will be displayed. So inverse of the matrix, to find the inverse of the matrix, we have a solve built-in function. So inverse of the matrix will be calculated and printed. We can have the row sum and column sum calculated for a matrix. Only rows will be added and only columns will be added by using these built-in functions. Say likewise, we can calculate a column mean and row mean on a matrices. Observe the outputs. This is the column mean and this is the row mean of a matrix. Here the sum means the total matrix will be added. Total means whatever the elements there in the matrix will be completely added and a single value displayed as a output. And you have a eigen built-in function that will find out the eigen values of a matrix. So these are the eigen values of a matrix. Observe the out. Thank you one and all.